Hello, this video is titled What is the Electrolysis of Brine? So of course this comes up on the GCSE spec underneath the electrolysis chapter. Electrolysis of brine is treated slightly differently to kind of other examples that you would have looked at already, because ionic compounds can exist either, well, they can be solid, but in terms of electrolysis they exist in a molten state or in solution. So for a lot of electrolysis, you are looking at compounds that are in the molten state, so they contain just two ions. However, when you look at something like brine, brine is an aqueous solution, so we actually are adding water, and water has some effects on electrolysis, and that's what we'll look at in this video. So really quickly, just what is brine? Brine is basically really concentrated salt solution. So you would have heard of things being stored in brine. So you can buy chunks of tuna in a can and it's in brine. You drain the brine off and then you eat the tuna. So brine is basically just salt solution. And it can be referred to as an aqueous solution. So electrolysis of brine is one example of electrolysis of an aqueous solution. Now, the electrolysis of brine produces three products, and you can see them there: chlorine gas, hydrogen gas, and sodium hydroxide. The reason I've included them is because lots of the time questions will ask you what are the three products. Sometimes they also ask you what the tests are for the three products. Chlorine gas, the test for it is damp blue litmus paper. You hold it in the gas and it will bleach white. Hydrogen gas, you place a lit splint into your sample of gas, and if it's hydrogen, the splint will give a squeaky pop. Sodium hydroxide can be tested using like universal indicator, because obviously universal indicator in water is green. If sodium hydroxide was present or added, it would turn purple because it is an alkali. Now, really quickly, I'm just going to talk you through kind of the ions that would be in sodium chloride solution. So when you look at the electrolysis of just sodium chloride, if it's molten, you'd be looking at there being two ions, Na plus and Cl minus, okay? But like I said at the beginning, the fact that we've now added the solution element, which has come from adding water, we've now got two other ions at play, which is H plus and OH minus. Because they have now been introduced to the solution, you can see that we've got two positive ions and two negative ions, and there's rules which dictate which ion will go to what electrode and why. So what I'll do is I'll really quickly just draw the standard setup. Some of you might have seen the electrolysis of brine done in a Hoffman, which is a piece of glassware that you can perform electrolysis of solutions in. I'm just going to do the really standard setup. Okay, so I've just got my two electrodes. Okay, positive and negative, and I've got my cell there. My electrolyte here is going to be the sodium chloride solution, which we've said is called brine. Okay, so if I was to put the two electrodes into my solution of sodium chloride, like I said, I've got four ions, Na plus, Cl minus, and then I'll do the two from water a different colour. I've got H plus from water and the OH minus. So my electrolyte has got four ions in. Well, you can see already that that poses a bit of an issue because you've got two ions, Na plus and H plus, that both want to go to the negative electrode. You've got Cl minus and OH minus that both want to go to the positive electrode. And there's rules which dictate which ones do and which ones don't. And I've got another video, it's an electrolysis video, and it's about the half equations in electrolysis. It's on my channel, and I give you the rules in that video in far more detail. But essentially the two rules are that if you've got two positive ions present in a solution, the less reactive one will go to the electrode, and it will be what we say discharged. Okay, so our two positive ions here are sodium Na plus and the hydrogen ion H plus. Now sodium is a very reactive metal, so the least reactive out of the two is hydrogen. So we will have hydrogen gas appearing at the negative electrode. Now with the other two, there is a second rule. If there are two ions present and one of them is a halogen, then that halogen will appear at the electrode. Now, we do have a halogen here. Chlorine is in group 7, so it is chlorine that appears at the positive electrode, okay? And therefore, you can see this is why two of the products of electrolysis of brine are Cl-, which will turn into chlorine gas, and H+, which will turn into hydrogen. Now, my third product was sodium hydroxide. Now, the Na plus ions and the OH minus ions stay in the solution, and they join together to form NaOH, sodium hydroxide, and that's how you get your third product. Now we're going to look quickly what happens at the electrode. So all students on all tiers, including foundation tier, need to know what happens. And I'm really quickly just going to talk through what happens. So I said that at the positive electrode, we would have the chlorine ion going to it because it's negatively charged. At the negative electrode, we will obviously have H+. Now what's going to happen is, really simply, the Cl- is going to turn into Cl2, chlorine gas, and the H+ is going to turn into H2, hydrogen gas. At a foundation level, you just have to be able to describe how the chlorine minus turns into Cl2. Well, the chlorine minus is a negative ion, and this is a neutral atom. So for it to be a negative ion, it at some point has got more electrons than it does protons, which is why it's negatively charged. So it has to lose that negative charge to become neutral. So the chlorine will lose electrons. Okay, and we call that oxidation. Oxidation is loss of electrons, reduction is gain of electrons. Now look at the positive hydrogen ion. For it to be positively charged, it's got more positive protons than it does negative electrons. So therefore, for it to get back, again, this is a positive ion, this is your neutral atom. For the positive ion to get back to its neutral atom, it must gain E-. Remember, E- is standing for electrons here. We call the gaining of electrons reduction. So what happens at the electrodes here is redox reactions. So the chlorine ion will undergo oxidation. It will lose the electrons and turn back into chlorine diatom or chlorine gas. The positive H+ ion will gain electrons, turn back into the neutral diatom, hydrogen, and it's given off as a gas. Now this is higher tier content only. So if you're not doing higher tier, of course, please do stay and watch, but it isn't something that you will necessarily have to know for your exams. Half equations describe what it is I just wrote down on the previous slide. What I had written down was the fact that Cl- turns into Cl2, and then I've got H+ turning into H2. I said that this was oxidation and this is reduction. Okay, now if I've taught you over the years or you've watched previous videos, I always say that the reduction half equation is easier. Okay, because reduction is a gain of electrons, so you are adding electrons, and we add the electrons on the left hand side. Okay, like so. I'm just going to move that arrow over quickly, like so. We add electrons on the left hand side of the equation. which is what I've done here. Now I'm just going to balance that out. We've got 2 H on the right hand side. On the left hand side we only have 1, so we must put a big 2 here. And now because we have put a big 2 in front of our H+, it means that 2 separate H+ ions are gaining an electron each, so we must put 2 electrons. That's your reduction half equation, and I always start with that one because it's easier, because the half equation, literally writing it out makes sense. You are adding electrons to your H+ ion. Now the oxidation equation is a little bit more tricky. We don't write the electrons being lost on the left hand side or anything like that. We write them as plus E minus on the right hand side. Again, I'm just going to move that up. So in an oxidation half equation, we write the electrons on the right hand side. The reason I say do the reduction equation first of all is because if I put the reduction electrons on the left, the oxidation electrons must go on the right hand side. Okay, now again we've got 2 chlorine atoms on the right hand side, and we've only got 1 on the left, so I put a big 2 here. If I've got 2 individual ions, each losing an electron, I must have 2 electrons over here, and they are your half equations, okay? I always suggest replaying the video, going back through it, again, pausing the video before I've gone through any worked examples and having a go yourself. But essentially this video is still talking about electrolysis. There's still half equations, but it's just talking you through the effect of water. The main effect of water is that it produces 4 ions, okay? And you have to make the decision about which ion is going to be oxidized and which is reduced. And rather than pick from 2 ions like you do from a molten compound, you're picking from 4 ions because it's an aqueous solution.